Okay, so before we continue discussing calculus, um, because calculus, I want to know how well you know about the function and then algebra, and then maybe trigonometry. Because I think these three especially important for calculus. So I will have some questions and try to answer. Okay. So first is how to obtain the domain of function. Okay. First is this function. You need just to find the domain. Okay. No need to solve or any. Okay. Just finding the domain. If you don't know the domain, don't worry. That's okay. I just want to know. Okay. For the online students, you can also try to solve these three questions. I'll give you maybe like 4 or 5 minutes. If you forget to solve, don't worry. Okay, it's not the exam. Do you need more? Okay. So number one, you need to find a domain of functions. You have two functions here. Okay. And number two, you have piecewise. I forgot to write this question. So sketch the function. So number two, sketch the functions. You have, it's called piecewise defined functions. Number three, you have two functions, f and g. This is called the composite function. Okay, but maybe you already know. It's like a circle in the middle. It's not fog. It's not always like a circle symbol for composite. Who still remember? Or who forget? Remember? No? Okay, okay. Good. Maybe you can try number two first, or maybe number three first, and then number one. Because today I will be discussing, focusing only on the functions and how to transform functions, how to combine functions before we go to the introduction of limit. Okay. If we have time, maybe we'll have a limit introduction today. If we don't, then maybe next week. Still okay. The first month, I want to take really faster. Okay. From these three questions, number one, number two, number three, which one is you think that you are mostly forget about all of that? Which one? Number one? All. No. Which one? From these three questions, one, two, three, which one is most for you difficult to understand? Who says number one? Number one? Okay. Number two? Number two? I'll check. Yeah, at least you get the idea. Okay. Yeah, no need to really good, just sketching. That's also fine. Uh, I don't know, in Taiwan or maybe in mostly in Asia, uh, especially from what I've experienced before. When I study math in maybe junior high, high school, there's a lot of exam for entrance to school, right? You need to take exam, and then you pass the exam, and then you get the school, right? Then you have the like passing grade for each school, different passing grade, right? The more highest passing grade, the more difficult the exam is, right? Um, but one loophole in that kind of system is we are trying to learn math by solving problems that maybe I know some of uh, culture like a tutoring, like one tutor, okay, and we and I also had experience like having a tutor, exercising math, but in that way, I only exercising my math only to pass the exam. I don't really get it why I'm writing that math notations and so on. So all the basic or fundamental knowledge of math, I kind of like, oh, it's important because I can answer the exam and okay, I get a passing grade. I go to the school. Okay, okay, all these three questions, basically the basic questions for function. Okay, so number one, okay, number one, domain. Domain means if you have a function, imagine the function is like a machine, okay, any machine, okay. You input the x, right, to the functions. You input any element, okay. And we name the element x usually in math, but you can actually make x and fx in any way you want. Okay, we plug in x to the functions, and it will resolve in let's say y. Okay, this is called the domain. Okay, and this is range, the result. So everything that we input to the function and that is making sense, makes logic in the function. So the function can works. That x is domain. But if the x is not working on that function, then that x is not his domain. So there's a lot of x, right? A lot of numbers. which number that makes sense to that function. All numbers. If all numbers, you can say, oh, all x in real numbers is the domain. So you can put in all x. Okay. So for these questions, okay, both of the function here, it's rational functions, which means you have this in the bottom another function. Okay. I don't want to get into detail, but can you divide this 1/0? Who say yes? No, right? No, right? I've already explained a little bit in basic math class, but I will not get into detail here. But at least this 0 is not making sense, right? So this one do not get 0. It should not get 0. So that's the first idea. Okay. So if I open up this factoring, can we factor it? I think we can. Oh wait, wrong. All right. Okay. So if you plug in x equal -2, it will be 0, right? If you plug in x negative +1, it also 0, right? So here the x should not be -2, x should not be 1, so that the functions make sense, or you can draw in graph, right? So you can write your domain here. There's no other number, right? You can put pretty much all the number. You can write the -infinity until -2. And then it's also start from -2 until 1, right? And then you need also to include the last one, 1 until infinity. Okay? Do you know what this bracket means? Okay? It means it's not including the number. Okay? If the bracket is like a rectangle, and like a straight rectangle, that means you need to include that number also. Okay? Just review. Okay. Okay. The second functions. You have square root in cube, square root of cube x, and then x squared plus 1. From the first functions, you know that this one should not be 0. This also should not be 0. But you also have this, right? So in square root, how should we proceed with square root of cube? Oh, how about this is just 2? Okay, just 2. And then we have 3. Okay. If we put -8 here, is it making sense in the real world? No, right? It will be we need to involve an imaginary number. Okay. But if you have cube here, and it makes sense, it's -2, right? In real number, it's making sense. So the answer will be, what is the answer? You can say all the element real. Yeah, I think it's all real, right? 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 Any negative here, it will be positive. Any zero also keep zero. We cannot make it zero here, right? It's always positive. Okay, so all real number. Ah, and then number 2, sketch the graph. Mm, it's actually if you make continue like that, and then from here, from the 0, you have 2x plus 1. So you get, yeah, more or less like that. Okay. We will have more details about the piecewise defined functions in limit. So we'll get to that. So FOG, what is FOG? Means F, right? Okay, it's called the composite functions. So if you have F like that, and you have G, so what will you do is you need to put this G, go here. So making this G into this X. Okay, so you need to square, multiply 2, and then minus 1, and that is FOG. And the same with the GOF. We call that the composite functions. Okay. 3A, oh, 3A is FOG, G is in alphabet. Sorry, I just read your chat, Pong, right? Yeah, it's the composite functions. Okay, any questions so far? Remember? Okay, that's I think basic in the functions. Okay, I did one more. Okay, just one more question. Mm, let's say we have. Let's say I have this function f(x) there. Okay. This is y equal fx. And the question is, can you sketch if y is plus 2? Okay, sketch this tree. Okay, just one more, and then we can go to the introduction of the function. So first one is negative fx. Number 2 to fx minus 1. Number 3, fx minus 3 plus 2. This is actually, you need to maybe, it's better if you can imagine like function in your head and then shift it. It's probably faster. But if not, you can try to draw and then imagine. Yeah, you can say that the fx is just x, y equal x. That's okay. Making things easier to calculate, also fine. Now I want to know if this is the fx, what will be the transformation if we had negative here? And if we multiply by 2 and then minus 1, what is happening? If we change the x into x minus 3 and then plus 2, what is happening. The graph, it can move, right? It can stretch, right? But where the graph will be moving. Okay. If I have this -1, what do you think? Going up or down? Going up or down? Yeah, down. It will be down here. And this is going up. X -3. Going left or right? Okay, good. Good. Okay. I think you at least understand the logic. I will draw for you, and then we can, I think we can go for some proof in another website. Mm, so if this fx, then this is the negative. Okay. So this is fx, this is negative f. And then if this is fx, this is from here. Yeah. I think this is fx. Then I will shift 3 to the right, just here, and then +2, maybe here. So maybe, yeah, it's not parallel, but yeah, I just make them parallel. So fx -3 +2. Okay. This one, okay, the fx and 2fx. If you remember way back when you learned gradient, the more steep gradient is, right? Like when you climb and then you said the gradient is getting larger and then it's become like this. It's getting more and more vertical. Okay? That's why when we have 2, we need twice stretch the graph. So it doesn't matter if it is like this one, then you need to like imagine it's being stretched like rubber stretch, and then it's making twice as much. So to help you maybe getting a visually better, let me present. Uh, yeah, just start with the x squared. Wait a moment. I need to present. Okay. So you have x squared here. You can move this. So if I plus 3, it's going up 3, right? If I minus 2, it's going down 3. Okay. So if 3, so x minus 3 squared, what's happening? So when I have minus, it's going right. When I have plus, it's going left for the x. Okay. Okay. Please keep remember this transformation. Okay. Okay, back to our screen here. Okay. Okay, so I will start the chapter 1 about functions. Since you are familiar with the functions, I will just mentioning the key points. Okay, so x, and this is a function, and this is officially. Okay, so this is the functions. Um, let's say this is set of rule. Okay, assigns x in a set of domain exactly one element of fx. So that x in domain, it will exactly a set one element. So we can write also in math notations. We have x and fx, so that the x is element of the domain. If I don't want you to memorize this, okay? Just makes logic in your thinking. That's okay. You don't really memorize the words. Don't memorize the words. I think it's better if you memorize just the graph. I think the graph is much more easier. Visual is, I think, easier for some people. So if this is your function, y equal fx, and this is your y-axis, x-axis. Okay. Okay. So what's the domain means? The domain is here, okay, and the range is here. Yeah, I think this graph is way better to look at. So this is actually the first one is domain. The range is set of um, possibility value of fx. Okay. So range depends on domain. Okay, depends on domain. And also FYI for your information, it's not too important, but how to represent function. First is verbal words. Second, you get this table of values. Three, graph. Four, algebra. Okay. Okay. I think with what verbal means is like this definition as blah 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 blah. A function defined as in each element blah blah blah. Table of values means you have x, fx, x, fx. Each number have each function, each range. Okay. And graph is like you make a graph that's also represent the functions. And also algebra. Algebra means using a math notation. So like x greater than 0 or x less than 0, that's algebra. Okay. Just to name some terms that you will find in calculus. Okay. But usually, uh, just knowing algebra is it's fine. You can do all. Okay. By the way, anyone knows what algebra means? Algebra means? No. When you solve like x squared plus x equals 0, what you are doing is algebra operations. That's algebra operation. So you you know how to use algebra, but literally the algebra means the words. Okay, I mean the words. It came from Arabic words. It means to fix a broken things. That's literally what does it mean. And the book, the algebra, the first algebra books, it's literally means to fix a broken things and balance it. So that's why you need to have like equations, solve the equation. Then that's the algebra. The literal meaning. Okay, so uh, for representation of functions, okay, I think that's um, quite simple and not really difficult. Okay, I will go to the next one. Okay, or do you want to write this first? No, I think it's. I think you already know how, but you don't have the words to say, right? If you have like problem in math, you know how to solve the problem, but to define or to explain what it is, you need to maybe you need to think a while. Okay. Okay. I want to talk about domain first. Okay. About domain. Okay. So domain, I will write again set of all possible inputs of functions. Okay. So I will just name a few, and this is already include all important functions in calculus about domain. What you need to be taken care of is if you have any rational functions. Okay, any rational functions, the part in the bottom should not get 0. Okay, the first one, A. Or B, if you have square root something, okay, this one should be uh, greater or equal 0, right? You can have 0 inside, right? But negative, no, right? This should be, so this is square root. And then third, if you have log, what do you think of log? What is log? You know log, but why? Why we need log? Log is actually like a scaling. Like you need to scale some numbers. Maybe the numbers is in like 10 million, and then the next one is 100 million. It's too much number, right? And you need to simplify and making log. Log 1, log 10. Log 1 is 0. Okay. Log 10, 1. Log 100, 2. It's easier, right? Easier. So if you have like hundreds, thousand, it's easier to make a graph making log, especially if your database is like really high in number. So can it be 1? Yes, right? It's 0. Can it be 0? A negative? Yes. No. Yeah. So it should be greater than 0. So logarithm. Okay, I think this tree includes all the domain problem, mostly in math. Okay. The rest, you just write, the domain is all real number, right? Okay. But careful. In domain, you can also mix and match all this problem. So maybe here and then having at the bottom the other functions is also possible, and also log and then having square or maybe some equation here is also possible. Okay. Then you just need to mix this all variations. Okay. But the most important in domain is just these three, and let's solve all problems. Because the other way is domain is all real numbers. Because basically all x is you can plug in as much as you want to functions, unless you have this kind of function. Okay, for online students, do you have any questions? No? Um, understand of the course? Okay. And then another thing about functions, there is called even and odd function. So you have even functions, you have odd functions. Um, or do you know even functions, odd function, or you just learn now? Even there's even and odd functions. Okay. So example, okay, example, even functions, example is x squared, the easiest one. It's x cubed. I think it's too small. Okay, so what is the most different in this x squared and x cubed? If you have the graph, this is just like that, right? What about the x cubed? It'll be more steeper here. No, no, no. But it has that way, right? So when you have negative x here, it will be negative, right? If you have the cube, -1, it will be -1, -2, it will be -8. But here, all will be positive, okay? So I think that's get you some idea that if you plug in negative x, so even if you plug in negative x, it's still the same fx. For odd, if you plug in negative x, it will be negative x. Um, even and odd functions is not too useful in application, but some sections you can explain by odd and even functions. But I think um, it's easy and um, not not really that difficult. Okay? That's it. Is the even and odd functions. And then the next one. Or do you have any question so far? I think it's just reviewing what you have learned. Okay? You have learned before. Okay, the other one is piecewise defined function. Let me make it bigger. Okay, this is what I already asked you before the questions. So you can have like two state of functions. So if I have these two conditions, okay, 1 minus x, but my x is less or equal -1, and x squared if it is greater than -1. Okay? So f, I think this is easy, right? F -2. So if x is -2, then f -2 is, because we know that 1 minus x is less than -1 and -2 is less than -1. We use the first one, right? Okay. So it would be 3, right? And what -1? Is it 1? So we still use the same, okay? And 0 is greater than, so it's just squared 0, plain 0. And how the sketch? So we have x squared from -1, 1, 1 minus x is pretty much the same as y equal x, but you need to shift the graph maybe around here. Yeah, maybe there. Yeah, this is just reviewing a little bit. Okay. All of you already scanned the QR code, or you need the QR code? Who's not scanned QR code? Oh, okay. Wait. Yeah, you can. If you want to write, you can write first, and then I will show the QR code one more time. Yeah, you have it. Yeah, yeah. Wait. I will show you. Hmm. Okay, I will show you the QR code. Stop sharing. Okay, this is the QR code. If you find difficult to scan, you can just go to front or maybe take picture in my laptop. And also for online students who didn't scan the code before, you can scan now. Okay. Okay. Um, okay, so online students, have you scanned all the QR code? Okay. 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 So back to the piecewise defined functions. Uh, I need you need to familiar with the piecewise. Okay. Um, maybe we will come for problem in limit. Okay. For the next one, there are several. We see some essential functions. Basically, we will see all of these functions in calculus. So from the linear, um, the power functions, squared, cube, fourth, root functions, square root, okay, and then reciprocal. Reciprocal mean 1 over something, 1 over x, 1 over x squared, etc. And then exponential and logarithmic. And see this log is always here, and in 1 you will have a 0. Yeah, better if you at least remember the essential one. Like for example, the log, exponent. You don't need to know what is the number r. You need to just to know uh, just a few numbers that are important, like one here, one here. In the exponent, it's one also here. Okay. Yeah, this is basically what we have done in the questions before. Okay. So this is your functions in the middle. If you want to move up, you need to plus a constant. Move down, minus a constant. Move to the left, you plus the x. Move to the right, you minus the x. Okay. I think it's not too difficult, right? Mm, Another one here. This is a stretching and reflecting. Okay. So your function is here, right in the middle. Here, this y is equal f of x here. Okay. If you are multiplying the function with the constant, you get the stretching function, stretch function. Or is if you multiply with 1 over constant, you get this function. And if you reflect the function to the x-axis, you get the minus f of x. If you reflect to the y-axis, then it means the x become negative x here. And then I think for composite, you already understand, right? The composite functions. Composite functions is these symbols like GOF, F, F, or you can have like infinitely composed function. Yeah. Yeah. So this means this. This means this. This means this. And yeah. Hmm. Hmm. I think it's you get the idea. Uh, okay, maybe you have learned before. Okay, this is called 1-to-1 functions. Okay, if you have uh, if you have this two arrow going into one dot, then this is not 1-to-1. So uh, 1-to-1 functions, if you have x, it will be different whenever okay, why 1-to-1 functions is important. Okay, so let me write let f. So if you have inverse, okay, another thing that I need to mention is the inverse. Okay, so if you have 1-to-1 functions, okay, domain A, range B, the inverse is switching the domain. The domain becomes B, range becomes A. Okay. Hmm? Okay. Have you checked the temperature here? Oh, you have, yeah, yeah. Next time, just press the AC. Okay. Yeah, I also realize it's too hot. Okay. So next time, if you get into the class, just press the button. Okay. But I think the previous class, it depends on me. You need because you need to have the AC card. I think this building, you just press the button. And if you want to like blow more wind, you can actually adjust the blower. Good, good. Because I actually wondering why it's so hot. It's hot. I thought the AC is turning on. Okay. So um, the inverse. So you need to switch the domain and range. I will go to solving how to solve. Okay. So if you have maybe x cubed plus 2. Hey, do you still remember to find the inverse? Let's try this one. Do you still remember how to find the inverse of this function? We have the functions x cubed plus 2 inverse. Feel cool now? No, no, no. Why? Yeah, wait maybe 2 or 3 minutes. I think it's getting cooler. Okay. Okay. Anyone find anything? Who still remember? Remember? I think, yeah. I think. Yeah, I think, yeah. Okay. Um, the way we are going to solve it is write down in y x cubed plus 2. You can also just use f of x is fine, but I prefer to use y because later I will show you how. And then solve the x into y. So x cubed is y minus 2, right? And then x is square root of 3, right? And then remember that all the domain is A, all the range is B at the beginning, and then switch, right? So we need to switch this x into y, and then this y into x. So this is the F inverse. Okay. Okay. Online students, do you have problem? Any questions? Yeah. Yeah, yeah, sure. Or do you want 5 minutes break? No? 5 minutes? Okay. Okay. 5 minute breaks. Okay. It's okay? The AC? Okay. Yeah, just wait 1 2 minutes. Okay. At least I already give you a preview about uh, the functions, the foundation of the functions, and also um, the element of the functions, just a few of them. But I want to just go to our subject. So as I mentioned before, the calculus is mathematics of all things that change. Okay, which means you have a rate of change. And remember that I mentioned the calculus is from this small pebbles, the literal meaning of calculus. Okay? And to illustrate, okay. So Newton, even though like I said before, the Apple story, I don't know whether it's true or not, but at least the Newton he discovered when he put some like a ball and he dropped the ball, uh, the ball it's getting faster and faster, and that's what intrigued Newton to find what it is. So if the apple going down, why the moon still there, not going to the earth? That's how he think about something happened there, something phenomenon in physics. But he needs tools to understand that phenomenon, and that's why he goes to invent calculus. So what he did is, so this is, let's say this is force, okay, like any force. For this case, it's gravity, the gravitational force, and then this is the distance. Okay, let's say you have this. Okay, um, and then let's say the graph is like this. Okay, so if you have, let's say, so if you have like a ball, okay, the cut this cut, okay, you cut this ball here, okay, you cut the ball, cut. Uh, this division is called the secant. Wait, this is called the secant, and then he need to cut until it touch this here, touch here. So maybe like that, okay. And by the way, that's called the tangent. Okay, tangent means from it's from tangible. Tangible means it's only touch at least touch uh, accurately 1 point. It's tangible. It is from tangible. So if you know how it works, then when you heard tangent, you probably will know that, oh, it's touching 1 point, 1 point, exactly 1 point. Okay, so this is what he did. Okay, so if this is A, This is B, and you have this line here, the second line. Um, let's say this is fx. Oh, wait. So you have this x plus h, and you have this h distance. Okay. So what Newton did, he cut all through his functions. He cut through until, or maybe it will be easier if you have this B point. Imagine this B point moving here, getting closer to A. Okay. So when it's moved, and when the B reaching A here, it will precisely tangible in A. Okay, and from there, or let's say, if you remember, the tangent is the tangent is here. So the gradient or the tangent is the fx plus h, and this is the fx, right? Okay. If you see the triangle, okay. So this part, so this part is fx plus h minus f of x, and this is h. Practically, this is the gradient, and then um, he need or we need some tools to understand the how big getting closer to A. So it's getting closer, closer, closer. We need another language. We need another tools. Okay, that tools is called limit. So when we say limit as h getting closer to zero, so how we read this limit? If you have lim x or any variable arrow 0, we can read this as limit as h getting closer to 0. So limit is actually, you imagine in the functions that thing is moving to some x, okay, or some variables. Okay. So he developed limit, and then from here we can write down the gradient. So this is the first basic tools that calculus needs. Okay, um, we call this derivative dy over dx. Okay, the next one, I have um, this is y equal x squared, and let's say we need to find equation of tangent line to the uh, y y is equal x squared at point p(1,1). Okay, so the point is here, p. Okay, so if we uh, imagine if we haven't learned any derivative, it will be difficult. But there's a way, and it's similar to what Newton did. So let's just take any point here, Q. Let's say this Q is, of course, because it's x squared, so we have point x and x squared. and this is 1, 1. So if we have gradient, it will be x squared minus 1 and x minus 1, right? Okay, remember the gradient. Uh, okay, just linear equation gradient. So here, what you can do before you learn derivative is you can try approach some x and some x squared. So maybe try x is 1.1 and find the gradient. So you plug in the x, try find gradient, and then try again, find this, and try until you're getting closer to 1. And then you can prove what kind of gradient that it will become. Okay. My answer and my calculation is if you have 1.1, you have 2.1, and then 1.01, you have this, and then this, and more 0, and getting close to 1, you have 2.00000 until maybe almost infinity. Okay, almost infinity. But from here, you get the idea. Oh, if we approach this q from right, if we approach q and then approaching p, we're getting 2.0000 something. Okay. If we have another point here approaching from 0 to 1, we also getting similar. So if we maybe making r here, so maybe we are trying from 0 and then trying 0.9 because it's near 1, right? And then 0.999 and then 0.99999, and then what you get is this is 1, this is 1.9, this is 1.999. And the thing is, when you keep getting closer from right and from left, you're getting at least similar number. It's getting closer to 2. It's not exactly 2, but we know that it's getting closer to 2. But because we learn limit, and the limit is finite in 1 point, we can say that the limit is 2. Okay? So the exact point, okay, the exact point, if you don't really use limit, you cannot make that point become 2. No. But because you are using limit, then you can make a conclusion that this 0.0001 and 1.99999 is getting closer to 2. And you get conclusive or conclusion that, okay, the answer is 2. Okay? Okay, so limit is not exactly the point is this, but it is your conclusion when you are getting closer to something. Like you want to reach something, but you cannot reach it. Actually, you cannot reach it, but you know that it's really, really small gap you will reaching there. For example, okay, uh, I will give you the it's called the Zeno's paradox. So Zeno, let's say a person called Zeno. Okay, okay, and then this is a wall. Okay, so the idea of Zeno's paradox is so this guy he can only move half of a distance, and after that he can move half of the previous distance, and after that only previous. So if this is this 1 meter, so he moves until half, and then after half he can move 1/4, And after that, 1/8, 1/16, and so on and so on and so on. Can he reach the wall? Can he reach the wall? The question. No, right? No. But in limit, he can. Okay, understand that? So limit is actually, you are not getting there, but you are really, really close, like a really small point. So every mathematician in the world, I think, they don't really know what those small, small means. They just imagine, oh, there's like a really, really, really small. But what small that small thing is, they don't know. I don't know. We know it just for tools for our math in our imagination. So this is one example, Zeno's paradox. Like if you remember, like Sn, I think the for infinite series like this, like for one half or not one, from half, fourth, and this is until n reach infinity. You can actually count this, right? You can count this by this. This is n should be less than 1. The ratio should be less than 1. The ratio is here. Uh, you need to multiply by half, right? So the answer is, if you think that from half, it's actually 1. So in our limit, this is limit, but I think this is for the calculus too, but just for information. Okay. I think you also get from high school, right? Yeah. Okay, that's uh, the sense of limit. Okay. Okay, I think one more and then we can finish. Uh, do you need to write this? No? Okay. Okay, another thing. Um, I think this is the same thing as before, so I'm just skipping it. This is just example. I will go through. Wait a minute. So let's say I have, this is 450 meter. I have a ball here. So the ball drop. Okay, ball drop. The question is, find the velocity of the ball after uh, 5 seconds. So there is no time interval. So you have a ball drop. The distance is 450 meters. You need to find the velocity after 5 seconds. So the ball drop and after 5 seconds. But you cannot do anything, right? Because you don't know how to approach the, at least, functions or models that you need to establish, right? But I will give you the models, okay? So actually the models is from the Galileo Galilei. So he came up with this function. He came up with these functions. He came with these functions, okay? So because we need to calculate after 5 seconds and there is no time interval, so let's assume a time interval. So let's make our own time interval. Okay. Uh, so from t equal 5, let's say t equal 5.1. Okay. So our average velocity So it's changed its position. Just reviewing up physics a little bit, and then time elapsed. So this is the position model, s equal 4.9 t squared. Okay. So by using this exact functions, so from s 5.1, s5, let's say it's time elapsed from 5.1 from 5, so it's elapsed 0.1 second. Use the functions, plug in and calculate. Yeah, you don't need to calculate. I will write it for you. It will come in for 9.49 meter per second. But we need to know that is it true that after 5 seconds, this is the velocity? We need to try different interval. Okay? We need to try a different interval. So let's try different interval, because the question is we need to exactly 5 seconds. So we need to getting closer to 5. So we establish models to getting closer to 5. So before we already done this, this is 4949. Try 5 until 5.01. Okay. And then 5 t 5001 and try 0000 all 0 if you want. And we are getting closer to this number. And the 0 is keeping adding all the time. Okay. So when it is getting closer to 5, it's closer to 49. Okay. So this idea is getting closer in this velocity. It's called instantaneous velocity after 5 seconds. So this is called instantaneous velocity, the idea. Okay. The same idea when we are dealing with the graph and limit is also the same idea. We're also using limit here. Okay. So I think in also physics it's called instantaneous velocity, and then in how it works in next session, or maybe you have learned before, you just can derive, right? You just can derive and then you can get the answer directly. Okay. But how actually it works is we are getting closer like this. Okay. We need to calculate exactly after 5 seconds. And how we are doing that, we can establish models and establishing any number that closer to 5 and see how different it is and see that it is actually making a pattern. Okay? When it is getting closer to 49, we can assume that, oh, if we add more 0, like this is really small gap closer to 5, then it's actually closer to 49. And that is our idea of instantaneous velocity. It's actually the same as we are dealing with limit before. It's actually the same thing happened. Okay, I think I need to just to stop here. Okay, we will continue next week. Um, I hope you get the idea of limit. Okay, and like I've said before, we will start slowly. Okay, getting all the concept done, and then go for different application tools and etc. Okay? Because there's several notations tools that you need to learn. Okay.